Let angle ABC be a right angle triangle with angle C is equal to 90 degree such that AB is equal to 25 and side BC is greater than side AC and the radius R of the inscribed circle in triangle ABC is 5 centimeter. Let also CD be the height of the triangle ABC from vertex C to side AB. Find the radius R1 of the circle inscribed in triangle CDM where M is the midpoint of side B. Now look at the diagram. ABC is the right triangle. That is, this is the right triangle with the right angle here at vertex C. Formula for the radius R of the inscribed circle of a right triangle is R is equal to half A plus B minus C, and that is given to be 5, where A, B and C are the lengths of the sides BC, CA and AB as shown in the diagram. Here, vertex C is the point of right angle. Therefore, this side AB is small c. Similarly, vertex A, the opposite side of vertex A is BC, and that is equal to small letter a. And the side opposite to vertex B is AC, and this is written as small letter b. Since R is equal to 5, that is equal to half A plus B minus C, we get A plus B minus C is equal to 10. But it is given that C is equal to AB is equal to 25. Therefore, because A plus B minus C is equal to 10 and C is equal to 25, we get A plus B is equal to 35. Let us call it equation 1. If you do not know the formula for R, that is this formula, then please see one of my videos to prove it. Now, the area of a triangle is given by the formula half R multiplied by A plus B plus C. If you do not know this formula, see another of my videos to prove it. For the time being, let us assume this formula for the area of a triangle and apply it to the triangle ABC. For triangle ABC, R is 5, A plus B is equal to 35 from equation 1 and C is equal to 25. Therefore, area of the triangle ABC is equal to half R multiplied by A plus B plus C, that is equal to half multiplied by 5 multiplied by 35 plus 25, because A plus B is equal to 35 and C alone is 25. And if you perform this operation, we get the answer as 150. Since ABC is a right triangle with angle C is equal to 90 degree, this angle is 90 degree, its area is also half base into height, that is equal to half A into B. This is A is equal to this, B is equal to this, and they are at 90 degrees to each other. Therefore, area of triangle ABC is half A into B. Now, we have already found out the area is 150. Therefore, half A multiplied by B is equal to 150, or AB is equal to 300. And from equation 1, we have already found out that A plus B is equal to 35. From this equation, B is equal to 35 minus A. Therefore, A multiplied by B is equal to 300, and when you replace the value of B as 35 minus A, we get A multiplied by 35 minus A is equal to AB. Therefore, 300, that being the value of AB, is equal to 35A minus A square. By rearranging terms, we get A square minus 35A minus 300 is equal to 0. If you factorize the left hand side, we get A minus 20 multiplied by A minus 15 is equal to 0. Or A is equal to 20 or 15. This is a quadratic equation in A, so it will give two values for A, 20 and 15. Similarly, therefore, B has to be 15 or 20, because A and B multiplied together has to give 300. So 20 into 15 is 300, and 15 into 20 is also 300. However, it is given that BC is greater than AC, or A is greater than B. Hence, A has to be 20 and B has to be 15. Before going any further, please like, subscribe, share and hit the bell so you can be immediately notified for new uploads. It's completely free and only takes a few seconds, and you can always unsubscribe later if you want to. More importantly for me, if you like, share and subscribe, it would encourage me to make and post new videos for you to view. Also, if you know about any interesting problems that you would like me to solve, please upload it in your comments. Without further ado, let's proceed with the rest of the video. Also, area of triangle ABC is half CD into AB. That is, area of triangle ABC is half CD into AB, where CD is the normal dropped from D onto base AB. Let us call CD as H, and note that this angle is 90 degree. That means this angle is also 90 degree. Hence, half CD into AB is equal to half H into 25, because it is given that side AB is equal to 25. Therefore, half H into 25 is equal to 150. Therefore, CD, which is equal to H, is equal to 150 multiplied by 2 divided by 25, that is equal to 12. Let us call it equation 3. Now, CDB is a right triangle, that is, CDB is a right triangle with this angle being 90 degrees. Now, this vertex D is connected or joined to M, which is the midpoint of the hypotenuse CB. Hence, the length of DM, that is this length, is equal to half the length of BC. This is half the length of BC. This is also half the length of BC. And these two half lengths are equal to this length dm. It is also well known that dm divides triangle CDB into two triangles of equal areas. That is, this is the right triangle, this is the line joining D to the midpoint, then the area of this triangle is same as area of this triangle, and each one of them is half the area of this right triangle. That is, area of triangle CDM is equal to area of triangle DMB is equal to half of area of triangle CDB. These are well-known facts about right triangles. If you do not know the proof, see in any standard geometry textbook. I will also try to post a video proving these two things. In the present case, BC is equal to A is equal to 20, it is given in equation 2. If you go back, you will find in equation 2, we had found out the value of A to be 20. Therefore, dm is equal to half of BC is equal to 10. Let us call this equation 4. That is, this is 20 and this is therefore is 10 and this is therefore 10, which is A by 2 is equal to 10 and A by 2 is equal to 10. And we have just now discussed that dm is equal to this, also equal to this. Therefore, dm is also 10. Let the radius of the circle inscribed in triangle CDM be r. This is the circle inscribed in the triangle CDM, and let it have a radius r1. Then area of CDM is equal to half r1 multiplied by the sum of CD plus CM plus DM, which are the sides of this triangle. We have seen this formula earlier in this video. And therefore, area of CDM is equal to half R1 plus H plus A by 2 plus H by 2, because this is H, this is A by 2 and this is A by 2. So the area is half R1 and H is 12, A by 2 is 10, A by 2 is 10. Therefore, area of this triangle is 16R1. Let us call it equation 5. Now, let's calculate the same area in another way. In triangle CDB, that is this triangle, this is a right angle triangle. This side is 12, this side is 20. Therefore, we can easily find out this side by using Pythagorean theorem. Or BD square is equal to BC square minus CD square, that is this square, is equal to hypotenuse square minus the other side square, and that is equal to A square minus H square. A is 20, so it is 20 square. H is equal to 12, so 12 square, and that is equal to 400 minus 144, that is 256. So BD square is 256, so BD is equal to 16. So this length is 16. Therefore, the area of this triangle will be half base into height. Okay, half CD into BD, that is equal to half CD, or H is 12 and BD we have just now found out to be 16, and this works out to 96. Therefore, area of triangle CDM will be half the area of the triangle CDB, which is equal to half of 96, that is 48. But we have found out the same area to be 16R1 in equation 5. Therefore, we get 16R1 is equal to 96, and so area of CDM is equal to half multiplied by 96 is equal to 48, and that is equal to 16R1. Therefore, R1 is equal to 48 by 16, that is equal to 3. So, the radius of the circle inscribed in triangle CDM is 3, and that is the answer. Thank you.